Still trying to think about what is better to do today. I'm going to continue working on the stuff, but uh, I don't know which one is better to do. There's two different options. One is to start parsing the hands here, and the other is to figure out the node ID algorithm. I don't know which one to do. And also, I'm thinking about trying to figure out the algorithm to create the bats as well, so I don't rely on saving the lines on the file. And here it seems like it was working. I put an extra waits for solver line, and then yesterday it works, but I realized that when I saved from the river, I saved with the wrong stack and pot size. So that's the problem, is that if you solve from the river, you need to get the stack size you would have by that point. So it's not the same thing. So you either need to solve from the flop, or you need to keep track of the bats and from the line you're taking until that point in the river that you have the ranges. And yeah, so that becomes more complicated, and that's the reason why I think that is better to focus on figuring out the algorithm to create the lines, and also figure out the algorithm to get the node ID, because I'm thinking about creating the simulation from the flop. The other thing that I realized is that I can solve spots, but I don't need to save them. And this might be useful if I wanna, for example, just create the solutions to test, to get the EVs, and to like do some exploration. Obviously that would take a long time, but then like all I have to do is just create the code once, and then I would wait for the whole thing to finish running, even if it takes like more than a day to do it, or several days. Because if I did it like that, it would allow me to see the spots that are leaks, I think, because then you are running with the data, and then you are solving in real time, and then you get the solution, and with that solution you know what spots, like, so I want to do some data analysis things, like maybe do some plots or something like that. I'm still thinking about ways that, because the biggest challenge is to figure out exactly what are the spots that you're wrong at. Like, it's not very easy, but it's relatively easy to know, like in a general sense, what you need to improve. But it's really, really extremely hard to know exactly in what kind of situations you are not doing that. So for example, let's say you don't call enough. It's relatively easy for you to understand you don't call enough, but it's extremely hard for you to know exactly what situations you're not calling enough. Like what positions and what cards you're playing, and what is the board texture, and that kind of stuff. So I think the best kind of tool is the one that is gonna allow you to see exactly which parts of the game tree you have to work on, and it has to be very specific. But the only way to do that is if you solve the data in real time, I think, and then you create something that does like an aggregation analysis of everything, and then it creates a hierarchy of what's important. But that's extremely difficult to do. This thing here now I was solving for the flop. In the river was working and it saved, but now I'm solving for the flop, and it was taking a long time because flop. Well, the good side is that it works. It waits for the thing to solve. At least to some. This is the part that is confusing, because it seems like it didn't go for the exploitability or the accuracy that I put here. I don't understand why this is happening. Like, it seems like it waits less time than it should for the thing to go. And now I put this stuff here, this process.wait, because this is a command from the sub process in Python, and it seems like this is supposed to make the thing wait for the execution to be complete. So I'm hoping that this is gonna make it work now. But I still haven't tested. But I think I'm gonna test this off stream. And then I was thinking, oh, the other thing I realized and is that I didn't change the range here, and it still worked. So I should have tested this before. Like I did all of the work of converting for nothing, pretty much, because it still works if you pass the dictionary, I think. Because this file is the dictionary of the cards, so I don't even need to convert. Yeah, so what I should have done looking back is just to do the script first and then figure everything else out. So now, which one do I do first? The thing is that my problem here is that I'm trying to string consistently every day, but for these kinds of things I have to think about, like, there's nothing I can do. Because they are really hard to know. And so I think the class of the node IDs, I should take the bats, all possible bats, and then translate them into actions, which are the lines on the thing, and the boards. And then create a tree that is based on that. And I think it has to be not in percentage, but in the actual value based on the starting pots and effective stack. I put some music. I'm gonna put 1 hour and a half here. I think I need to do the hand parsing first for the new format, but part of me thinks that is just delaying doing the hard stuff, which is the node ID. So I'm indecisive on which one to do first. It's hard to decide. I think creating the simulation is already considered as solved, because even if it doesn't work that well, I can just tweak there until it works. I don't think it's a big problem. I think the biggest challenges are the node ID and creating the bats. I think it's on the beginning here. Yeah. First decision nodes. Curious to see If anyone has done videos on this. I think probably not. And this sounds interesting. I think I'll look it up. Yeah, so there are no videos about. Actions are separated by column, semicolon, no, by a column. Bets are always a cumulative amount invested by a player so far. Bets are always a cumulative by a player so far. I think the biggest uncertainty I have here is what about the 3 bets? Like when you bet, they raise, and then there's another raise. Because the 3 solves that automatically for you when you solve directly from pile. So, and there's no specification here. That's my concern. Here it solves with the incorrect sizes because it's solving on the river and I'm placing the sizes there. I have to think about how I'm gonna create a class that keeps track of the bets of each hand and the hands. It has to be a dictionary where the hands are the keys and the value is another key with the decisions. But it seems very complicated. Okay, I essentially need to construct everything that shows here, but with the data. That's what I need to do. And then node lock the solutions based on the thing that was constructed with the data. That's the question, how to keep track of each action for each hand on each specific spot. I think it's better to figure out the preflop ranges first, then filter by position. Filter the hands by position. And then only analyze on those positions. The problem is that I probably need a massive amount of data because each flop is going to be different. So there won't, even though there will be many hands, there won't be enough hands on each flop, I think, on each different situation. So I think what I need to do is figure out a way to get the frequencies of lines, maybe, for each player, but then it's still like problematic because it's not very accurate. I need to figure out how to make the solver play against the data. That's what I want. Solver plays against the data. And the issue here is that it would require me to solve each spot, I think. which might take too long, I think. Another thing that it doesn't show here is whether or not, like, how is the first node decided. I think, let me think. I think the biggest difference is that the way that I'm building the preflop ranges is based on the frequency of when each hand is played, I think, in relationship to the whole data set. And I need to get the frequency of actions instead for the hand. So there's the hand and then the action that was taken with the hand. The problem is that I need to capture the street that is taken as well. You guys, like, becomes an annoying data structure to deal with. And then I would create the range the same way that I created the range preflop, and I use the set strategy here to node lock. That will be after I solve. Oh, I should do first, actually. Now that I think about it, I should create the script that creates the most amount of flops creates the solution for the most frequent flops, because that way I can just build like a database that is gonna have the solutions for these spots with the ranges. So first create the ranges, then create the preflop ranges, solve them, create something that solves all the ranges. Not solves all the ranges, solves the flops based on the ranges and positions, and then saves the solutions based on the same file formats, but in a different folder, different top folder. And then from the solutions, then I will do the node locking thing. To figure out the node locking, then I can use the solutions, and I can load the solution with the script. So load the solution, then put the data. I think it's better to get the data first. So I'll do the same thing, then I'll create this data structure that connects the hands with the frequency of actions for each street. Let's see node ID. I think I will parse the hands first. These things here. Because the other thing, I think it's not. The problem is not that it's hard, is that there's a lot of uncertainty of how exactly I can structure. But I think I just have to build and then test a bunch of times to see if it's correct. And I think the best way to do that is when I have the solutions already, because then like it's gonna allow me to compare with the real solution and the stuff that I'm building. What is annoying me is that there's a bunch of files already here, so I think I'm gonna delete this one just to print the hands, and I'm gonna start putting them. Well, this one I thought I would need, but probably don't need this as well. This example also don't need. Oh no, this is the data structure, so I'm gonna keep it here. I don't even know. Oh, this is from Pio, I think. Yeah, I'm gonna delete this. And I kinda wanna clean up everything as well. Maybe I'll create a different folder for the Bulldog stuff, so it's not. So I don't get confused with the other stuff. Most annoying thing about creating the folders is the relative imports and the way that I have to run the file. I still think I'm gonna use the same. Maybe I'll create a different class just for the Bulldog, and I'll change the functions slightly, depending on the cards. How do I get the information? I think I'm just gonna copy the parsense that I did for the other one and then just change what's necessary. Parsense, copy this here. And I should probably put these hands on that folder instead, this Bulldog whole cards. And the way that I did on the previous one is just run a script from the command line, the shell, the bash script that I got from the internet. I don't remember really well, but I think it uses the cat command. I also forgot the stuff that I learned about the commands from bash. But I know that you can just get all the files and then concatenate all of this into one, which I'm probably gonna do, or I can run the script. But I think I'm gonna put it on the same directory of the project there. I wanted to keep separated because then it's easier to... I think I'll do just a copy. I'll do all the cards here. So here I'll separate by month or whatever, and here I'll just put everything together. And I think that's fine because it's not gonna be that much, like it's not gonna occupy that much space, I think, memory. If it does, then I'll delete this one and keep this one. I think I'll just create a script to parse, to read all the files. Oh, actually, it's probably better to do that now. Oh, I think I'm gonna leave it like this and I'm just gonna loop over the files and read the stuff. I'll be right back. Yeah, so I think I can just loop over. I think most of this stuff I'm gonna have to delete anyway. I have to study the format of the file. So I think this one is pretty easy to figure out. So all I have to do is put Bulldog to determine the beginning and the end of the hand. I think I'll leave this here, I'll leave this stuff here. The thing is, it changes the whole logic of everything. Actually, it's a lot easier because I have the positions here already. Positions the stacked and small blind, big blind. And there's even the lines and the values. The only downside is that is under the gun +1 and under gun +2. And I think it's much better to just call middle position and cut off. I'm thinking about looking here to think about how I'm gonna parse everything. Like what kind of information I need based on the previous one that I did. I think this one obviously is not necessary, the whole position thing, so I'm gonna delete all of this stuff. I think the round's not necessary to... Let's see, pockets, cards. I'll get it from this line here along with the position. I think it's better to get the position and the chips first. I think I'm gonna probably delete everything here. I just use ChatGPT to get this annoying regex things that I don't wanna search for. The only thing that I'm not sure is the beginning of the hand. I think that I'm gonna leave that here. And then just change this for Bulldog. And this data structure I think I'm gonna change as well. Because the only reason why it is like this is because of the way that the data was before. And this is why I think that this one is gonna be much easier. Because I can create a different data structure here. But the challenge is that I have to think about what kind of stuff I'm gonna do after. And that's the problem. He's OS list directory. File name. Also think I'm gonna delete this. I don't even know why I put this one. Current game not in hands. Also, it's probably necessary to the story channel otherwise, but I think it doesn't make a lot of sense. Or maybe it does actually. Because hands is a dictionary. But I can make hands a list, I think. Yeah, I think that's better. Let's make a list. And then I just append. Yeah, but this way I'm not sure if it's gonna mess up there, so... for lining file. Because of the whole memory thing. That's once... but I think in Python it's fine. Like once you append this to the hands here, and then you change the values. Like, are you changing the original one or a new one? Like, in other languages it would be a problem, I think, because if you append, then you try to change here, the value here is not gonna live long enough, I think. Current round is not necessary. So, what does each hand need? Do you need the board cards? The players? Okay, so here it does show... I think I'm gonna join this. Instead of appending, I'm just join. And then it's gonna be... and this might be a problem. With the board, I'll do the same way that I did the other one. I think I can separate by position instead of players. It doesn't matter the name of the player. Unless it's me, because then I need to know, I think. Yeah, so it's better to separate as players, and then each player is a dictionary, I think. Instead of a list. And then the actions are gonna be inside of the player. And it's gonna be... the players is gonna be... but if I do it like this, I'm gonna put the position. I think I will separate by name again, so each is gonna be a nested dictionary. There's gonna be players, then the name is gonna be one key. Name. And what else? Position. A stack size. It's gonna be a number. Cards. Or just put cards. What else? Oh, actions. Actions is where it gets complicated because you have to separate based on flop, turn, and river. So I think it has to be a list. The great thing here is that it says that like what action it is instead of giving the value in number. So pre-flop happens right after the whole cards are exposed. The tricky thing is figuring out how to get the pattern because it's the same, it contains the same thing as the whole cards. So actions, I think it's gonna be a dictionary. And then it's gonna have flop. Oh, but that's the thing. This flop will have to be a dictionary again. It gets very complicated. Flop. You have bats. Maybe I just do a flop and then I do the actions. I think that's better. Because it's like do an array like this. And turn. And then later I'll think about, because this time I have the lines there. So it's easier. Oh, but the problem is that this is the thing, I don't want to couple the actions with the player. Because I need the sequence. That's the issue. So maybe I'll have to put actions separately. And then I just create the lines. Well, is that each player has to have... Like maybe I do... Action is gonna be a dictionary where... It has... The keys are players. No, but that doesn't make sense. The difficult thing is that later on I have to think about how I'm gonna use this, so each action is gonna have to be attached to each hand of each player. And so I need both the line and the actions based on the hands. And let me think when I'm constructing the simulation. So first I'll do the pre-flop ranges. So let's assume I have the pre-flop ranges and I have the flop solved. And then from that point I would get the data for what? I'll filter by flop, and then from the flop I'll get the players' cards and then the actions that they took with those cards. The problem is their actions are connected with the other players' actions as well. So I think purely from the data perspective, I don't need the other players' actions, because I just can attach the cards to the actions just with the players, because I know which actions they took in the hand, and I don't need to know the other player. But I think for the node locking, for navigating the node ID, I think I need the other player's actions. But then, like, what I can do, I think it's better to separate them and just... but then I don't have the order, that's the problem. Like, I need to know which one comes first, so I can create the line based on that. The thing is, for the stuff that I did so far, the order ended up not mattering that much, but the problem is that I didn't do the whole line thing, the node locking. And I think that's where the order is useful, because I need to create a tree structure of decisions, I think. And that's the whole problem. That's the reason why I'm not sure like which one is better to do first. I think that's where I'm stuck at, because the lines are gonna be directly connected with the tree that contains all the decisions on the simulation, and the node IDs is gonna be also related to that, and that depends on the tree bet sizes. I think that's the issue. They need to create I need to create a tree that has all the decisions, all the possible bets that can be made, and then get the line from that. But the other thing that I'm not sure is that, because here I'm using these fixed sizes here, but maybe it would be better to just construct with the exact sizes that were used each time. Yeah, but then that wouldn't be enough sizes, that's the thing. Unless I store them somehow for the whole data, and then I add all the possible sizes that people used on each specific thing. But then the issue with that is that it also depends on the amount of RAM that I have and how long it's gonna take to run the simulations. That's why I think it's better to have a fixed size, but then if you have the fixed size, then it's a problem, because I can't use the lines here for the simulation. I can make an approximation of the frequency based on how close the bet is. from when the... And the question is, how do I keep track of the actions for each hand? So I can have the frequency of bets or of decisions here for each hand. But do I need to separate them for that or not? I think right now I'm thinking that I don't. I can just do the actions separately here. So instead of putting them on the player, I just put them like on the other parts there. I put here actions, and then this way, like I would only need to put to make the flop, turn, and river. Because then the only thing that matters is for... Oh, but I would have to separate one level deeper for each player. So instead each player would have this, because I'm doing outside. But then the downside of this is that there's no connection between two different players. Like after I have the whole data, I'm gonna have the actions, but I'm not gonna know which one comes first. I can also put here in position or out of position now that I think about it, but I think that's also an issue, because if I put in position or out of position inside of the player, then it couples them too much, I think. Because let's say that for whatever reason I want to get data for multi-way pots, then I can't... I guess I can put there, but then it's like... I don't know, it feels that is not the best, because it gets too entangled. I think it's better to put the in position or out position on a class outside of this thing here. But I'm stopping here, I'm not coding anything, because I think that it is important to decide which one I should do. Because it is a fundamental decision that is gonna change everything later, I think. And the question is whether or not to create the data structure in a way that it connects the actions of both players, or create them separately, where the actions are only for each specific player. I think for navigating the node ID, you need the actions should be connected. That's the thing, because the node ID is going to be dependent on the actions. So I need to figure out a way to merge both, but in a way that it doesn't complicate the data structure too much. Maybe I can do... it doesn't seem like it's very efficient, but I can just do two different actions. One inside of the player and the other outside. The one outside has all the actions. Yeah, but then... I don't think. The other option is to create a dictionary inside of the actions, where each player contains... Yeah, but then it doesn't make sense. Because if you do like that, there's no sequence anyway. Does here have any information about the sequence? Yeah, I can get it based on, because it's the first one is the first one tracked, so it's in order here. Starts in position. Big blind calls. and flops. I guess I can just put the sequence there. So the action, instead of having this, I do need to separate bird flop and turn and river. The question is how I'm gonna structure this later. So it's root 0. I think I should do the node ID first. I think that's gonna be a better way. I should figure out the algorithm for the node ID. Because once I figure this out, then it's gonna be a lot easier to decide. The problem is that this starts from the flop already. But what I'm thinking about doing is not even putting flop, turn, and river, just putting the cards here instead. And then I don't put the board. But then it gets more complicated as well. Like if I just wanna, maybe I'll do both. Put the boards here, the cards here, and the cards here. I think what I want to do is just create the actions, like a tree with the actions. And then the boards, and then the other actions, and then turn, other actions, river. So maybe I should create a class instead of creating these actions here, and just... But then my concern is that it's gonna become too... Everything's gonna become too entangled with each other. Which is not gonna be good. If I put the flop there. I want to try to avoid doing the same way that I did on the other one, which is just to create a list and then put each object on the list. Because that is worse later, because there are a lot of repetitive things you have to do. Just if you wanna, I think it's better to create a dictionary, because if you wanna get information, you can just get through the keys. So maybe flop, turn, and river should be a dictionary instead. And I will do separately. And then the key is gonna be... Yeah, I think I can do that. No, let me think. It wouldn't be possible. The key would have to be the order of the action. And then the values would be the player, I think, and the decision. But... No, then I would have to create another dictionary. If I don't put flop, turn, and river, I think it's also bad. I think what I should do is just do one dictionary for actions and try to. It has to be a tree actually. I think I have to create another class and then just make this equal to the class. And then on the class I make a tree, and the tree connects the actions with the flop, turn, and river. So I initialize each action. I initialize each tree with the standard actions that I have there. And then I create an algorithm that approximates the bats with the ones that I have, the closest one. Then based on that, it creates the I'm thinking whether or not this is going to be inefficient because I will have to create the tree each time, each loop. So, and then, or if I can create outside of the loops and create only one time. But then that doesn't make sense because then how I'm gonna capture the data. And maybe I'm confusing the two things because like I can't think about a way to separate though. But this should be the first process where I just get the data and then I'll think about the other stuff later. But I can't think about a way to connect the two that is not going to be massively complicated or that is going to make things worse in the future. I should keep the sequence of the actions and to I think this way is probably the best way. And then I just append the actions here and then I create another component in the player called actions again, and it would have to be a dictionary with the bats. Bats. But the thing is, checks. Yeah, that's what doesn't make sense. I think this is not good though. That's the problem. Because I would have to separate here based on flop, turn, and river again, and then it gets like it is not good. And goes back to the thing that I was having trouble in the beginning, which is like this connection that's kind of confusing in my mind still, of the linked list with linked list of actions with the decision tree. I could just put the board, I think. That's easier. Or make a dictionary. Instead of doing flop, turn and river, I just put the board here. But then I'm gonna initialize this in the beginning. It doesn't work. I wouldn't do it here then. Like it wouldn't be explicit here. The boards here. Yeah, because that way I can use the index of the array, or just put them in order that they happen, and then I put the board here directly, instead of just putting the... Yeah, maybe I don't put the board cards here, because it's pretty much what I want then. That would be the node ID then, which is the boards. In this case, it starts from the root 0, but yeah, maybe I'll do that instead. I'll do root 0 first. So I'll do the boards and I'll do the actions, but I'll initialize just with the root first, and then if there's a turn, I will initialize it. So I'll put the root 0 here. And that way I'm kinda getting the node ID for each hand already. Which are the actions that happen in the hand. Yeah, that's the thing. I think this way is the best. So I get the node ID for each hand, specific hand, then later on I create the tree with all possible bets and raises and all possible decisions based on the bets that I have here. But the only downside of this is that I will have to approximate now, I think. So I have to calculate the size of the bet in relationship to the starting pot. And then I will see which one is closer to the ones that I have here, based on the type of hand that it is. And maybe I'll just put the... because on the node ID is the actual values as well. I will put like this, and then if I want later, I can create the algorithm and just change the list so that the bet's fitting on the simulations that I have. And then I can link later on as well the board cards with the node ID from the actions. So make this the parent node and the other ones are the child nodes. And that way I get the data. Now how would their hands be connected with this? Yeah, each card has to be parts of the node ID. So the node ID contains the dictionary of the range inside of the class. I think this is the best data structure. So that's what I'm gonna do. And then I just leave the... because this way is gonna be a lot better to optimize later. So then what I have to do is create the... We'll do some comments. On turn, creates current sounds. Turn cards. Yeah, so that way I create the tree one time that contains all possible actions based on the... So the flop is going to be the parents on the class, and then from the parents you have all the bat sizes, and then I create the algorithm that adds the lines, and use the algorithm that adds the lines to create the tree of all possible actions for that flop, and then turn in the river. And then with that class, then I can use this thing here to search how frequently each action navigates through, each hand navigates through the tree, if that makes sense. So the hand starts at the top, and then depending on the data that I have, which is gonna be this, like it's gonna be, I'm gonna use this data for each hand, and then I'm gonna get the aggregate of them all. The cards have to be inside of the players because... Oh, I can't do it like this because it's gonna be... Unless I do a list for each one, but that doesn't make sense. And that's why I did a list on the previous one. Because obviously then there can only be one key for each thing. I think I'm gonna have to do the list of dictionaries for the players. And the actions I'm gonna leave it like this. And do it the way that I thought. Oh, the issue, I still have the issue though, of that not being able to... I have to start the actions on the players as well. Unless... No, I do need. Because I need to know which one, if it's in position or out of position, that took which thing. Yeah, it's so hard. That's how I'm gonna... I need to know like what player took which action. So I need each player to have each action as well. Yeah, I think I'm gonna have to do the list, and then each list has a dictionary containing the player. And then each player is gonna have to have an action as well. I think I need to leave these actions separately because it's gonna be a lot better to create the node ID with this. Because this is like the line that happened in the hand, which is the node ID that is currently searching, like it's currently going through right now. So it's like navigating through the hand tree based on the data here. Let's say in the hand someone checked, I can just go through the list and I go through the actions here that happen in the hand. And that's gonna be the node ID that I have here. So it's gonna be easier to construct the node ID if I do the actions like this. But then the downside is that I don't... Like, I have to know... I have to associate the actions with the player so that the... So that I know what line it is, like which player did what. Because later on I'm gonna have to approximate as well the actions. And obviously I'm gonna have the link here because these are gonna be in sequence, and then if I put the actions inside of the player and do like flop, turn and river, then I can associate by, because I have all possible actions for the player, and then I have this sequence here that happen, and but then that doesn't make sense. Like, I need to merge the two together. There's no other way, I think. If I create another dictionary, then that's terrible as well to append inside of here. I don't think I can ask ChatGPT as well because it's not going to be good for this. So what do I do? The only way it seems like it would be something like this, the index, and then the... But then it would be separate than the player. And then here would be the player, and then the action that was taken. So maybe I'll create two different ones here. I'll put this as node ID, and the other one as actions. And I do like this. There is a dictionary of dictionaries. I forgot that I have to do like this. And then we'll have the index here, would be the priority. It will be like this. Yeah, I think this way probably works. Maybe I don't need the node ID. Oh, the node ID would be good. Like, this way is better because this way allows me to associate the cards as well, not only the sequence and the player. But if I put the cards on each dictionary here, is not good also, I think. So I think it's better to separate them like this. Then obviously inside of the player I wouldn't have actions. It would be just this, and then the key is the sequence, like the order that they were taken. The key here is the player, and then the action they took. But then I think that makes sense, because then the other action would be just a new index here. And then the player and the action. Yeah, I think that's what I'm gonna do. The downside of this one is that it doesn't contain the flop turn and river. But then I can get from this one. The thing is, I'm thinking because I'm not really sure if it's necessary to have the index. That's the thing. Like, I don't know. I think the only importance of associating the player with each action is the creating the betting tree in the end. Yeah, I think it's better to associate because I already have the sequence here. But then if I do board here, then I have to do a list again. Or I can do flop, turn, and river, and just... But then it's better to put inside of the player, I think. Yeah, I think I don't need the order if I'm gonna use it like this, so it might be better to just put inside of the player and then I just do actions. And I do flop, turn, and river. I think that might be better. Flop. And then I just put without the order. Turn. And I put them in sequence of. So the order is gonna be the index on the list. And it doesn't matter that much that it's not explicit. And that it doesn't connect the cards because then here is gonna connect the cards, I think. And then this is gonna have to be a list, I think. But I remember it was annoying as well, this thing. Unless I do a nested dictionary, I think that's better. Yeah, so I do this dictionary inside of this one. That's much better. Because then later on I don't have to loop over all of the players to figure out, like, to get information about them, like the cards. I think that's the reason why I thought that it was inefficient to have the list, is because after you go through the information, you get the who is in position, who is out of position, all the kind of stuff. Then you need to loop through the players again, even though you don't want to necessarily, because you want to get access to the information directly. I think it's better if it's a nested dictionary. And then the actions. And the actions are only going to contain, that's the main difference, is that on the roots ID here, it contains all the actions. And on the player, it is only the actions for the player. So this one I'm going to use later to build the frequencies, I think. Yeah, I use this stuff to build, like, I'm still gonna have to loop over them and then create another dictionary outside in the same way that I did for the preflop ranges. But it's gonna be on a better format because this is like navigating the... It's like getting these bats here. All possible bats that happen. or all possible decisions, and then it doesn't really matter the other opponent's decisions because all that matters is the frequency that the actions were taken with the hand. I think that's the key. Like the other opponent matters because of the node ID navigation. That's the difference. So I do need both, but and that's where it gets annoying because it's hard to think about a way to combine both. There's not going to be too entangled or not have the information that I need. But I think this way is perfect. Because then later on I can just use this action object to get the frequencies of the actions of each one. And this is going to be a path on the other class. That is going to be a tree that contains all the possible actions based on the root ID. It's going to contain all possible... The parent class is going to contain all possible roots, all possible cards in the root. This node ID is going to be the traversal of the either back first search or that first search on the tree of the specific action that is happening here. And this thing I'm going to use to get the frequency of the bets that of the decisions that were taken at each point of the node ID. Yeah, so this action is not here, so it goes inside of the player. And so far, I think that this is correct. Let's see if there's gonna be any problems with parsing the hand. So I think for this I'm gonna use ChatGPT to get the information. So it's gonna start, let's start from the beginning, then I think about it more if it doesn't work. I think I'll paste the hand first, and then I'll ask a bunch of questions later on how to get the information. Okay, so now and I have to convert this under the gun +1 into position. Maybe it's better if I copy the data structure that I have here. Fuck, doesn't work. It's better to just write on the IDE. It's gonna be... I tried to uncomment everything, but it didn't work. Oh, no, it works. Not sure why it wasn't working before. It's gonna be like this. And players. Players. Actions. And so first lines here, I'm gonna update the positions, the name. Create the player, then with the position and the name. Create the player with the position and the stack. And also should ask how to put hero for the player name when there is a me on the thing. I can also just copy the code that I already have for the other one. But I think here is gonna be a leaf. And that's the tricky part because there are some of them that are the same. I think I'll use chips on the first ones. Let's see if there's any edge cases here. I think all of them are gonna contain chips on the when it's declaring the positions in the beginning. And the thing is that they are not in order always, but I think it doesn't matter because you could just get the name and it's fine. I can do by the name actually instead, now that I think about it. Yeah, but I'm not sure if it's better to do on the outer thing. I think it is probably. So just put the condition if it is this, if it is dealer, then I initialize the player based on this value. I think I need to check though for this first. Yeah, so I'll parse from this line first to get my position and stack size and that kind of stuff. Then I'll do the other conditions for the other positions. Or maybe it's better actually to get, I don't know, because this doesn't have information for, it's better to just get the stuff, the initial stuff here, and then I would just use the position to get the cards. Yeah, so let's focus on the getting this stuff first. I think ChatGPT is very slow because a bunch of people are using probably. So I think I will start with this pattern here. Close everything else that I'm not using. I think I'm gonna copy these ones and then I modify there based on the line that I have. And the problem is that it's different because the line is different, obviously, but So I think I need to put the condition of AND chips in the thing, because there's other lines that there's me here, and I don't want to run it on those lines. I think I'm gonna stop and then do this stuff off stream. I'm just streaming today because of consistency, just so I can stream very often, but like that's the issue with doing the streams like this, because a lot of this stuff, there's nothing I can do on stream here. I have to think about it, and like it takes time. Like there's nothing I can do, so and this kind of stuff here, I think it's better to just wait for ChatGPT to come up with something instead of spending time searching. This is just a lot easier, and obviously just getting the patterns here. So I think the most important thing I figure out, which is the data structure here. And I think this one is gonna work. So what I'm gonna do probably off stream is just get all the patterns from the string based on this data structure that I created. And then from this data structure I can create everything else. Like the preflop ranges are the easiest one, because you just get the cards and the board, or the cards and the position for each one. But the ones that are difficult, and the reason why I spend a bunch of time thinking, is because I have to think about how to navigate. The navigating part is the difficult one, or understanding how like the tree is gonna be after I get all the data, and how I'm gonna update the ranges based on the tree format. But I think this way is gonna work, which is I have the node ID, which is the current path that the hand took inside of the bigger scope of the whole, all the possible paths that exist on the tree, which are going to be based on these bat sizes. And then maybe I'll see if I can include, or I'll probably have to create an algorithm that either approximates the bats here, or that uses those bats to add those bats again on top of the ones that I have here. But I think what I'm going to do is just approximate them, because the issue is the size of the tree. So it's better to have a fixed number of bats and then limit the size of the tree. And these bats here are already made based on the data that I had, so they're not going to deviate too much from these sizes, I think. So just create an algorithm that searches for inside of these arrays here, which is going to be a data structure inside of a class, which one is the closest to the bats that they made. The issue here is that the bats are going to be like the actual value, and here is percentages, so it's annoying. So I might do the other way on when I'm creating the data structure. Like I create the percentages, then I get the stack. I make the bats on the data structure be the actual value of the bat based on the percentage and the starting pots. So I populate the data structure with the actual values of the bats, of all possible bats in all streets. Then I create a tree of decisions that contain all the possible bats and all the possible decisions. And that's going to be all possible node IDs. And then from the data that I have, each one is going to be updating the actions that were taken by the players that I have the data from at those paths. So it's like updating in real time the actions that they took in the hands, based on all possible actions that you can have, based on the bat sizes that I have. And then from that point, because I think I'll have the solved solution first, so create the thing that solves the solution first, based on the board cards and the bat sizes that I have. And then from that point, that you're updating the tree based on the data, based on the actions of each point in the data, then I think you can node lock, because that's gonna be the whole no locking thing. So this class that I'm thinking about, which I'm gonna use to navigate with node ID, and the actions is gonna be the class that creates the node locking, because that's gonna contain all the ranges that are updated based on the data. And then I load the solution that I have from the flop, and then I node lock the ranges based on the dictionary that I'm gonna get from traversing the tree based on the node ID. That's the thing. Because this relationship is still a little bit confusing of the ranges, because this class is gonna contain multiple different IDs, I think. It's gonna be a tree, so each node of the tree is gonna contain a dictionary of ranges, of the range. That's the thing. And this is really hard because I don't have experience with creating trees, so it's hard for me to think about like how I'm gonna add the nodes and also delete them. I think I'm just gonna add and not delete, because it's gonna be all the actions. So it's more like how to construct all the tree with all possible actions, then how to create the algorithm that navigates them, and then how to structure the node so that it contains all the information that is necessary to update the tree later on. I think that's the biggest challenge, but I'm gonna have to think about, like, there's nothing, I'm probably not gonna be coding as much, it's just more about thinking a lot on the structure, so that once it's very clear in my mind, then like the code becomes the easy part, I think. Yeah, so I'm gonna do this off stream here, the parsing of the string, and depending on how long it takes, I might come back today to see if I can start. I think I'm gonna, maybe I won't stream either. I won't stream tomorrow as well. Maybe I'll take more time to stream now, because I think I just have to sit and think a lot about this, about how to structure everything, and then once I have like figured out at least the beginning parts, then I come back and I stream, because then I can actually code all of the stuff on stream. I think I might do that, so it might take me a long time to stream again. Maybe 3 days from now, 4 days from now, I don't know. But I want to finish this as fast as I possibly can, so. Because once I have everything set up, then what I'm going to do is not touch this anymore. I'm just going to play a bunch of hands until I have enough data to have relevant things from this. And then while I play a bunch, I'm probably going to shift my focus again to making videos or to writing articles. So I want to do that as fast as possible. But yeah, I'm going to stop here. I'm going to do all of this stuff off stream. So see you